Virtuosity is Bentley's e-commerce platform that provides an easy, affordable way to purchase practitioner licenses of Bentley software, paired with expert services, training, and mentoring.
Thank you for joining our webinar today. This session will be focusing mainly on OpenRail Designer, on how it can help you design your turnout faster using its specialized tool. We also show you the advantages of using OpenRail Designer over other more commonly available civil design software. My name is Casey, your host today. I'm a product consultant for Bentley Civil Software. Together with me is Milan, our product expert for our civil software. She has a wealth of experience with our road, rail, and site design products that include conducting numerous training and delivering professional services to our users in the region. She was also a practicing professional before she joined Bentley.
Okay. Okay. Good afternoon, everyone. So great that we have or we got things working already. So I'm Milen. Okay, as mentioned by Casey, I'll be the presenter for today. We will be focusing more on OpenRail Designer. Okay, but specifically the design and modeling using some geometry tools for turnouts as well as corridor modeling. Okay, how you can utilize OpenRail on such scenarios. Okay, now before I start, I would like to launch a poll question. So for those who are in the call or in the webinar, what projects are you currently involved in? So just feel free to click anything so that we can more or less get to know the attendees today. Okay, and then check if everyone are in the right webinar. Okay, so far we are getting 100% for transportation projects, road rail. Okay, there are 6% more or less who are doing land or site development project. Okay. Okay, so I think I shall close this now and share the result to you guys. Okay, so again, you're in the right webinar. Okay, so let me try the last one. Okay, so in rail project, so for those who are doing rail projects, okay, what do you feel is the most challenging to design or model? So a rail in a tunnel, a rail on a viaduct or a bridge, rail depot or yards, and then the at-grade type rail corridors. Could be any types of track, single or dual. Okay. There. Oops, sorry. I forgot to click the launch button. Sorry. Okay. So there. Hope you can see the poll question now. Okay. Okay. So keep those votes coming in. Okay. So more than half have already voted. So let me just close the poll question and share the results to you. So it's good to know that 80% are, or not really good to know, but I think you are really in the right webinar or session, because 80% of you are saying that they're having a challenge in designing rail depot or yards. So basically, okay, uh, it's in a way what we intend to show in this presentation. So how you use tools from OpenRail Designer in designing or creating turnout geometries as well as corridors. And then some would see a sample of at grade or even a tunnel type of rail later on. So yeah, it's good that everyone are thank you for this uh, information, okay, that you shared with us. Okay, so moving on with the presentation. Okay, so let me give a brief overview of first of the Bentley Civil Designer product family. Okay, some of you might have heard of Open Roads Designer. Okay, I'm mentioning Open Roads Designer first because this is our main civil design solution, and most of our civil design solutions are actually built on top of Open Roads Designer. Okay, but for today, our focus would be OpenRail Designer. Okay, but we have some on-demand as well as upcoming webinars as well from Virtuosity as well as the Bentley events in our website, focusing on Open Site Designer, Open Roads, as well as the Open Rail Overhead Line Designer. Okay, now in terms of how Bentley has been improving our solutions specific to civil design is that we are making sure that we are following or more or less are always along with what is in on along with what is up and coming as well as the current technology. So from CAD to BIM, and we've been hearing digital twin nowadays. So our civil design solutions are basically geared towards meeting the demands of the technology that we're having currently. Okay. Now, as for OpenRail Designer, okay, which is the focus for today. Okay, so it's an all-in-one package basically, because you can do road design, you can also do site design, and it's built on top of our MicroStation Connect edition for all your CAD tools. And apart from that, you can do drainage and utilities and do hydraulic analysis, integrate some geotechnical bore log information. And then, of course, everything starts with survey. So you have those survey tools as well. And then if you have to integrate point cloud data, raster imageries, as well as reality meshes, we also have the cart. And then when all the models are created or designed or modeled, you have a tool that will allow you to output it into a nice visualization by using Lumen RT Designer. Okay, so all these packages or all these functionalities are in OpenRail Designer at one install and no extra charge for you. Okay, now to be specific, okay, for OpenRail Designer, so everything you see in black here on the left side are basically common for Open Site Designer, Open Roads, okay, and of course OpenRail Designer. But for all the rail specific tools, we have, of course, rail alignment tools for vertical as well as horizontal design, and the focus today, which is turnouts and sidings. Okay, regression tools, which allows you to design or create geometries, maybe along a brownfield area. Okay, and make sure that you're still following the right design standards when you're creating the alignment. Okay, and speed and cant are very important aspect when you're designing your alignment as well as your corridor, because you have to make sure that you are reflecting what is the correct or right uh, um, application of the super elevation that is along the alignment. Okay, and if you wanted to have more detail, you can add rails, you can add sleepers, you can even do some swept path or clearance checks, and then a minor overhead line electrification modeling. Okay, although if you would go back to this Bentley Civil Designer family, if you need to have the full capability of designing, okay, based on engineering principles, the overhead line designer, okay, is the software for you. Okay. Now, moving on to some of the specifics functions of the software. Okay, before I focus on the turnouts. Okay, basic as well as traditional survey data. Okay, or formats or data formats can be used and utilized inside OpenRail Designer. Okay. And as I've mentioned, you don't only support those conventional survey data, you can also integrate point cloud data. Okay. This could be applicable both for design as well as asset management aspect of the rail. Okay. Then with along with the technology, okay, that has been improving, okay, every now and then, very fast, right? We have a support for reality meshes. Okay, this is actually meshes or surfaces derived from different photographs and stitched together using context capture, and you can use this terrain or as a basis of your terrain model. Okay. And of course, we uh, we are able to create terrains, okay, in OpenRail Designer, so that it could be the basis of your modeling, especially if your corridor or your project is at grade. Okay. Now, before we move on to the turnout itself, it is very important to know that the software, okay, has the power of creating and designing alignments, be it horizontal or vertical alignments. Okay, we have some CAD-like tools, but then these are not just CAD graphics. But you're able to create intelligent and rules-based type of alignments. And this is the same technology or tools that you use in Open Roads as well as Open Site Designer. And you no longer, unlike other applications or even our older versions, for those who have used MX Road, in roads, okay, the alignment is not anymore external, okay, to the design file itself. It is embedded in the DGN file, which is basically the format of OpenRail Designer. Okay, and we're able to support also those other third-party geometry file formats. Okay, so combining both the horizontal and vertical tools available in the software, you're able to create, as I mentioned, interactive by using the interactive geometry placement and editing tools of OpenRail Designer. Now, specific to rail, okay, specific to rail, of course, we since OpenRail is really an engineering tool that allows you to really create rail alignment. So it supports this kinds of rail alignment. And by utilizing, or maybe looking at the type of transition curves or spirals, you're able to really reflect, okay, the the requirement, okay, for your rail alignment design. Okay. And regression, okay, can also be done using the software, so that you can make sure that you're using an engineering based way of of designing your alignment, be it horizontal or vertical. Okay, we have some quick regression tools, and also some well-defined tools that allows you to make sure that your alignment is properly created, especially if the project, as I've mentioned, is in a brownfield area. Okay, now moving on to the main topic. Okay, so turnouts are more or less one of those tools in OpenRail Designer that can be used to create simple turnouts. Uh, there is this placement and creation turnout creation tools. Okay, and the latest version, which is the OpenRail Designer 2021 release, uh, one. There's also release two that has just been released early this year. So we have actually updated some tools there in order for you to make sure that this turnouts that you design are rules based. Okay, and it would actually combine also the 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 typical geometry tools that you would use in road design. Okay, and specific to the turnout standards. Okay, so the software supports extensive turnout types, be it single or double turnouts. Okay, and looking at this figure here, you would see that we support almost all those global standards that we have in modeling or designing our alignment. Okay, for crossings we have these types. Okay, but if you're not seeing anything specific to your locality or your country or country from where your project is, these standards are configurable to follow different industry standards. So let's say, for instance, you're not seeing Singapore, for those who are doing projects in Singapore, so if you're not seeing any of the standard Singapore here, then all you need to do is just go to our downloads or software downloads center, then download the Singapore data set, so that you'll have an additional Singapore data set there. Okay. This also is true for the Australian or ANZ region, or even maybe Hong Kong or other regions. Okay. Now, with OpenRail Designer, okay, as I mentioned, if the typical start would be just to create the main rail geometry. Okay, and then using some of the horizontal as well as vertical tools uh, in a manner that you do it like as if you're doing a CAD like commands. Okay, but we have some specific rail geometry tools that allows you to really create the right geometry. Okay, in this case, turnouts, combining it with our horizontal as well as vertical geometry tools. So what you're seeing in the screen right now is a sample main uh, alignment. Okay, main alignment, and then we have two alignments that are offset from the main track. Okay, so with this geometry here already placed, okay, we'll be creating some turnout geometries. Okay, looking at how these were all designed according to, or created according to, um, and has dependency from the main alignment, which is the long red line that you see here. So using the place turnout tool, okay, and as you can see here, it's pretty much straightforward. All you need to do is launch the command and then change the settings according to your desired result. Okay, placement point would, you would need to understand the schematic of how you do your placement. Okay, this is available in the documentation of the software. So we have, at this point, I am using the by point zero, and then the start of the chainage is from the left or south. Okay, that's why it is indicated here that it's trailing. Okay, and what I want to do after I place the turnout is I want to connect it to this second alignment that I have. So using some extend turnout tool, I'll be able to connect this and combine the geometry, okay, by using a simple arc. Okay, and then inputting a specific radius value. Okay, I'll be able to complete the alignment. Okay, so this is one way for you to create the turnout. Okay, there. Now let me place another turnout here so that I can connect it to the third line that third geometry that you see in the screen. Okay, same step. Okay, but of course different position or location. Uh, okay, then what I want to do now is to connect this to the third alignment. Okay, now I'm just changing the name so that it's easier for me to identify the turnouts later on. Okay, now with the latest version of OpenRail Designer, we have this tool called Geometry Connector. Okay, so the Geometry Connector is basically a tool that will allow you to solve complex geometry types. Okay, it gives you a more engineering based way or method of defining and creating your rail geometry. Okay, so in this case, the line, okay, or the alignment that had been previously created um, needs to be connected to the turnout geometry. Okay, so by putting in some length as well as arcs, okay, and making sure that the orientation is correct, right? So let me just fill in some radius here, okay, to make sure that I'd be following more or less a specific standard or geometry parameters that I need to input. Okay, there. Okay, okay. Again, radius for the third arc. Okay. Now you can move on and create some more geometry. Okay, but in this sample that I'm showing you is it's enough for me to have line, two arcs. Okay, then if you notice, if there are things that are not correct, okay, the software itself would make sure that it cannot be done. Okay, notice the error that you see here. So what I would do is make sure that the hand or the left hand side of the arc is properly set. Okay, and then once I click compute, the software now would create some iterations in order for me to connect the turnout. Okay, there you go. Okay, now so that's how you can use other tools in order for you to connect your turnout to the main and other geometry. Okay, now what if you need to create crossings? Okay, so I've already created some turnouts. Okay, and I want these two turnouts connected in the middle alignment. So the tool I would be using is the place crossing method. Okay. Now, I can follow some standards by choosing a specific feature definition to make sure that I am doing it in a manner that it is engineering or following an engineering principle. Then combining it with some other tools to make sure it would eventually connect to the turnout. Okay, so there. Now you can do this step by using geometry connector as well. Okay, but you can also use some of the horizontal geometry tools, okay, that are available, because the software gives you really different, okay, or unique and um, different types of ways or methods for you to really design the turnouts. Okay, now this part is almost similar to what I did in the first one, so I'll just push this a bit ahead. Okay, but basically the final output is this one. Okay, there. Now it could be that you would need to create some crossings or turnouts in a yard, similar to what you're seeing right now. Okay, so we have some tools that will allow you to create crossovers. Okay, although in the latest version, because this one was actually created from the older version, but this tool has been replaced by the simple place turnout tool. Okay, but the gist here is that every time you're creating turnouts or even some simple geometries, and at any point that these geometries will be updated. Okay, so notice how dynamic, okay, the updates are. Okay, so I'm exaggerately moving the main alignment, but notice how the other, okay, alignments are following the main one. Okay, even if I change the chainage attachment, okay, of the yard, then the main or the other alignments would follow as well. Okay, so once you have already designed the all the geometries that you need, including the vertical assignment of or vertical profile of the alignments. Okay, the next step for you to do is really create now or generate now the corridor model of your rail track. Okay, now you can do different types. Okay, as long as you know more or less the principle of uh, or making sure you have the alignment with its vertical profile. Okay, and of course most important thing here is your cross sections or templates. Okay, so the templates actually represents a typical section or cross section of your railway or even your roadway. Okay, and the template actually has series of points, okay, or points that you create, which basically would then create the 3D linear features when you have the 3D corridor. And then the components, those closed components that you see here in the cross section, and the rendered one here on the right side, is representative of your 3D meshes. Could be pavements, could be your ballast, sub-ballast, or even sleepers or the side slopes or grading. Okay, and it is crucial that you know more or less the principle on how to create the templates so that you can create the 3D model of your corridor. Now, if I may just go back to this previous slide. So the 3D model itself is the design, okay? even though you're creating a three-dimensional model, because sometimes in some other application, or even if you're exposed in just CAD, right? Every time you can do 2D, you can also do 3D, okay? But then it's not intelligent. It's not dynamic, okay? But in OpenRail Designer, the 3D model itself is your design, okay? Then when you already have your alignment, or maybe you have your terrain, okay, you can now and then your template, okay, you can now move on and create your corridor model. And it's there are tools, okay, there are tools that will allow you to basically create and make sure that you reflect, okay, the design, okay, as you create them, okay. We have different tools or numerous tools that will allow you to design this corridor, okay, which you will see as well later on. Okay. Now, this yard here is actually the uses or utilizes the alignment that I have created a while ago. Okay. The first portion, okay, the first portion or the template drop would basically apply this cross section or this template, okay, for a single track. Okay. And then this other portion here, which represents our yard, okay, would actually apply this template here, which is wider, okay, than the first one. Now, it's, as I mentioned earlier, okay, you have to make sure that you know how the templates were created, okay, especially assignment of point names, so that you can use the corridor editing tools in order for you to depict, okay, right, in a right manner, the design scenario that you would like to to create or to achieve. Okay, so like for instance, using this latter part of our corridor, remember this turnouts that we designed earlier, as well as this two. Okay, so what I want now is to adjust this so that the corridor, okay, would adapt to the turnout. Okay, so how will I do that? I would be using or combining the corridor edit tool, which is specifically called point control. Although there are many ways actually to do this, but the best method would be by using the create point control tool. Okay. Now, from the command name itself, you are literally controlling the point of your template to adjust to a specific geometry. Okay, so in this case, the LO ballast, the point that I showed you earlier on, would try to make sure that it follows the siding track B, which is this second turnout that we designed earlier. Okay, so with a little offset on horizontal offset, okay, and then going through the command, okay, you'll be able to make sure, okay, so you see what happened on the right side of the screen here, that it actually adapted, okay, or the, the template actually adapted to the direction of the geometry. Okay, looking at it in cross-section view, so that more or less you know what just happened there. Okay, because in the cross-section view, you will be able to really see if the point, okay, or the point control that you applied were actually applied properly. Okay, so let me just adjust the cross-section view to shift to this turnout location. Okay, let me just, okay, so notice here, so this is this portion, okay, the magenta box that you see on the cross section is basically the LO ballast, okay, LO ballast point, which we adjust according to the direction of our turnout geometry. Then the cross section is being shown in the cross section view, and then notice how it smoothly, okay, transition from the yard location to the main line, okay, and there you go, until it moves back to the original template. Okay, there you go. Okay. Now, of course, well, once your corridor is done, okay, or probably prior to the corridor modeling itself, you have to follow and apply speed tables. So you can actually use the speed table editor in order for you to add a more specific design standard, okay, in this case speed table, and then this speed table can then be later on used by the Cant calculator or rail super elevation tool in order for you to depict how the the train or how the coach is adjusting towards the change in the geometry, specifically the curve that is happening along the alignment. Okay, now just to show you an example of this, so more or less this step is also similar to what I did a while ago. It's just that it's now showing you how the cant is applied, okay, to the corridor, okay, along the along the corridor, sorry, okay, and the points are basically constrained, okay, to make sure that it would adapt to your design, uh, okay, and we have tools that will allow you to test if your template would be applied properly. Okay, now let me just push this a little bit, okay, just to show you. This one is just more or less a step on how it references the corridor template, okay, and choosing the right template, then applied to the corridor, okay, and there you go. So zooming into the corridor, so we now have the 3D corridor there, okay, but let's apply the cant, okay, so that you would really see how more or less the train or the coach would adapt to the curve, okay, to the horizontal curve. So we have a rail geometry already created, or a cant geometry already created in this uh, file here, okay. So all you need to do is just assign it to the corridor that you previously created there. Okay, so once you have applied it, look at again the cross section so that you know if the cant has been applied properly. So using the dynamic cross section viewer, you'll be able to see, okay, again, notice there are three, okay, small squares, magenta squares that runs along the, or that you see in the cross section, okay, and notice now that the template, okay, looking at its cross section is adjusting to the cant calculation that has been applied in the corridor. Okay, there. Now, moving this forward, if let's say, for instance, you have to make sure that the turnout also reflects in the corridor model itself. Okay, so in this case, the step is similar to the previous one, wherein there's a flat, okay, flat corridor from the main line up to the two other alignment. Now, in this case, it's not anymore flat in the sense that it I mean the ballast, okay, is pretty much well defined, okay, such that you will really see a difference between the main line, then it goes to a bit of a flat sub ballast, and then again a well defined ballast again when it goes to the yard portion. Okay, so in this case, using the same point control tool, you are going to manipulate the point in the second template, which is actually the CL2 point, and then follow or adjust according to the turnout geometry. Okay. Okay, you see here? So from the single track and then going towards the track that has turnout, okay? So you see a smooth transition, okay, in your corridor. Okay, so the template is actually very powerful in the sense that you can really make sure that it dynamically, you know, adjusts according to your design requirements. Okay, now of course there's a need for you to really understand how these points are parametrically designed. Okay, and it's a bit it's not really that hard. Okay, all you need to do is really understand how to apply constraints, how to depict, okay, or or decide which one would be the point that would represent the center line, which point would be the one that would adjust according to the Cant or super elevation values that you will apply in the corridor. So like what you're seeing here, the sample now is a tunnel type of template, but um, it still follows the same principles regardless of any types of template. Okay, there, there. Okay. Now I'll show a sample of the tunnel type in a while. Okay. Now, if you would like to be more detailed in your design, right, you can add rails as well as sleepers. Okay, you're not limited to just stay with the ballast and sub-ballast and then the end conditions or the cut and fill. You can also add in rails and sleepers by using some of the rail and sleeper tools in OpenRail Designer. Okay, you can achieve something similar to this. Okay, and okay, you'd be able to make sure that if there are turnouts, right, it adjusts or adapts to the, or your sleepers would adjust to the turnouts that you have in your model. Okay, now let me just shift to my software so that I can see this sample here. So this is the finished corridor based on the corridor or the geometry that we created a while ago. So looking at the cross section, this is how the ballast, the sub-ballast, as well as the existing ground, okay, are referenced in the design. And then how the sleepers as well as the rails have been placed, okay. And then in 3D, you see it here, okay, there. Now, for those who would like to see a sample that shows a tunnel, okay, we have this sample here in the screen. So this is one, sample data that our team has created um, um, with a turnout, okay, okay. Here. So basically it's a bored tunnel, okay, if you can see here. And then maybe this is the end of the tunnel. This is actually at this point here, going towards maybe a portion of the rail from where the temporary, okay, parking of the coaches would be in, okay, there. Okay. Now, going back to the presentation. So if, let's say, for instance, you have to compute for volumes, we have tools that will allow you to get quick information as to how much volume calculation or volumes are there in your model. Okay. And since you are using, different components with assigned materials to your templates, you're able to really get a volume report of your materials, okay, or quantities. And then sleeper count can also be acquired by looking at the properties of your sleepers. Okay. Now, apart from that, before I end my presentation, you can also do swept paths and clearance checking, okay, by also using the principle of template creation. Now, with OpenRail Designer, you're able to create different deliverables such as reports. You can output your geometry, even your terrain to land XML formats in order for you to maybe support other softwares. Okay, create sheets, plan, profile, and cross section. Then we have tools that allows you to create labels that are reflective of the civil engineering information that are in the model itself. Okay, and apart from that, of course, the 3D model itself is that you design is actually the a deliverable as well. And then you can configure some of the properties to reflect different asset information. Okay, so this is just a sample screenshot of some turnout reports and maybe alignment reports that you would need to output, okay, in OpenRail. There. Now, some samples of drawing production or sheets. Let me just forward this a little bit, okay, so that I can show you the end result already. Okay, of course, typical. You finish the model. You have the geometry as the reference direction that you would use as a reference of your alignment, okay, or sheet models, okay, and then you can come up with a sample output like this. But as I've mentioned, everything is configurable. You can customize it according to your design or maybe project requirements. Okay, so this is a sample plan and profile. For the cross section, this is one example result. Let me just show this output. Okay, ahead. There you go. So this is an example of a cross section in one sheet, but you could also generate single cross section in one sheet depending on your requirement. Okay. Now, one good thing or one good function or output that you can create in OpenRail Designer is the design that you create is actually a visualization output already. Okay, you can use some visualization tools to check, okay, your design in a straightforward manner. Okay, like for instance, in this case, you can save views as you do it in your normal CAD software, okay, because OpenRail has MicroStation as well. Okay, and then we have this review tool, specifically the 3D drive-through tool that allows you to visually inspect the model that you have designed. Okay, and then from here, so maybe I'll change the display style so that more or less you can see that you can see the other, okay, the other components or objects that are in this sample model that I'm showing you. So it's actually a board, a dual board or two board tunnel, okay, running parallel, okay, in the alignment. And then now it's going through the station, okay, there. So if you have a model or a 3D BIM model of the station, okay, that could also be referenced inside OpenRail Designer, okay, especially if all are properly geo-coordinated. Okay, you can also depict some cross passages, as you can see here on the cross-section view on the left. Okay, so this is one of the sample, you know, way for you to visually inspect the model that you have created. Okay, and lastly, okay, you can also utilize the more high-end visualization tool available in OpenRail Designer, which is called the LumenRT Designer. Okay. Now, it's already part of your OpenRail license. You don't need to really buy or get extra software in order for you to have this kind of output of visualization. It could be high resolution still images, or maybe an animation or AVI like you're seeing right now. Okay. You can add trees, you can add, yeah, as you can see, I've added a train, okay, and some signaling overhead line equipments running along the corridor. Okay, and of course depicting, okay, the turnouts that you have actually designed in the corridor, as you can see here. There. Okay, so in summary, okay, so today I've actually introduced not only the turnouts and sidings functionalities of the software, but basically gave you more or less an overview of what OpenRail Designer really is. So it's an all-in-one package that allows you to do road, site, and of course rail, okay, alignments and corridors. Okay, and it has some additional functionalities as well, although of course we don't have enough time to really discuss about the drainage and utilities tool, some of its geotechnical data integration tool, and so on. Okay, so with that, I'm finishing my presentation here, and if anyone has some questions on the floor, just feel free to type in the chat box. Okay, so
Hey,
that's all for my presentation, Casey.
wow, what a wonderful presentation and demo from Milan. So yeah,
Thank you.
there's some question coming up from the floor. So there's someone asking, is there a quick way to review the crossing and turnout bracket? Check on the turning radius and angle.
Okay, great question. Now when you're creating your geometry or your turnout geometry, you have a way to inspect them. Okay, by using some tables. Okay, or even reports, so that you can check the integrity of the geometry that you're creating. So we have that actually in the software, so that as you create them, you getting the right feedback if your design is following the the right standards that you have actually applied.
Okay, I hope that
That,
answers the question to the person
mhm.
who was asking that. Okay,
Okay.
we move on to the next question. Someone is asking, does the template calculate the throw for every curvature for swept path as mentioned? So I think this person asked it when you are showing the swept path template.
Okay, okay. Um, Actually, there is a way for you, because the swept path is actually, if I may just, although I did not show this a while ago, there's actually a way apart from creating it using the template, right? Because it's also following the template principles. Okay, so once you have actually placed it, okay, and then there is a tool that would allow you to calculate for some offset distances, okay, in your corridor model. So in this example here, if you can see, this is the swept path generated, okay, but you're able to still using the template tool, you're able to visualize or create this scenario of putting in some of those facilities, or maybe lines or points that would run along the alignment, and then create an offset report, okay, or a report that shows you how much if you see here, this portion here that basically uh, runs alongside the clearance. Okay, then you have the station offset report, so that it gives you how much, okay, is it, or how much distance of offset was it from the main alignment, as well as the specific point in the what you call this, the template that you use for the swept path. I hope I came in clear.
Okay. Yeah, let's move on to the next question.
Okay.
This person is asking if Indian standard turnout are inbuilt in OpenRail.
Um, I'm not aware of any, this design standards added, but I think, okay, if I may just wait, if I may just because I'm not too sure if they have it customized, okay, but if you're looking at here, so this is, I have the SG standard here, but yeah, I think there are Indian standard as well if you look closely there. I hope this answers the question.
Okay.
Mm-hmm.
All right. So, yeah, any more
Reading
questions
the,
from the floor?
yeah, I think, yeah.
Yeah, there is.
Okay. Mm-mm.
Okay. Yeah, if there's no more question, I guess if after this, when we send the recording to you and when you watch it again, and if you have anything to ask, you can just email to me or Malin as well, and
Mm-hmm.
we'll try our best to answer the best as we can. So, yeah, before you go, as you close the webinar panel, you'll be led into a survey poll question, which will help us to improve in the future. For future webinar, you can suggest the topics that you want us to cover in the future. So, yeah, until next time, I guess that's it for now.
Okay. Thank you.
Right. Thanks, everyone.
Apologies again for the technical issues earlier. Thank you.